Hey guys, welcome back to Chemchris TV. This video we really want to focus on relationship between KP and KC. Relationship between KP and what KC. So this video uh, uh, relates towards chemical equilibrium. You get? I've done some videos on chemical equilibrium, how to write equilibrium constant expression, and how to do some calculation. Then I've also done the second video on how to calculate Kc for a particular reaction when under reaction is being given to you. So then I've done videos on that. You can go check out those videos. They'll be at the description below. I will advise you to go check out those videos because they relate to what we are going to do here. So, what the relation between what Kp and Kc? Kp is what is a equilibrium constant in terms of what partial pressure, in terms of what pressure of what of the gas. While Kc is what equilibrium constant in terms of what concentration. So this means pressure. This means what concentration. K means what equilibrium what constant. So what's the relationship between what Kp and Kc? So the relationship is this: Kp is equal to what Kc RT this what N change the word N. You get? So we are considering this reaction A plus what B giving you what C plus what D. Now there's a way they derive this equation here. I'm not going to derive how we got this formula here because it's not that too important. So, but if you're interested to know how Kp and Kc are being derived, how we got this formula here, you can check you can check other videos which other content I've done too. You get? We have tons of videos that explain how they derive this one here, but this video I'm not interested on how we what got this one here. I actually want to use this formula here to show you how you can seek questions on there. So you really want to have your calculator. It's very important here. You want to have your calculator with you. Then you really want to have your pen and your notebook to take down every single thing I want to do here. If you have any question, you can kindly leave it at the comment section. If you have any question, you get. And if this video help at some point, give it a like and comment. I want to hear from you. It's very important. It help me to know that you on the other side watching this content actually what getting value. It's very important. I hear from you. Thank you for that. So now Kp is what is a equilibrium constant in terms of what pressure. K is what is a equilibrium constant in what terms of what concentration. So let's define this one here. So how is what is gas constant? Gas constant is okay. And the gas constant we are using here, you are using what 0.0821 liter per mole per what kg. So you really want to take note of this one here. This is what you are using here. You get? Then T is equals to what temperature. And when solving questions, temperature must always be what in Kelvin. So you always convert what Celsius to what to Kelvin by adding what 273.15 to any of what of the equilibrium any of what the temperature given to you in what Celsius what form you get. Then what about this change in N? Change in N is equal to what? Now you are using here. So it's the summation of what of the mole of the product. So the mole of the product here C plus D is mole of the product. So here we have C plus D minus then minus summation of what mole of the reactant. So here we have A plus what of B. It means that if a question is being given to you, you must checkmate if the reaction is what is balanced. So you have to take some down. So these are the stuff we are going to look at. So we are going to look at three key questions in this video here that will explain the concept to you on how you can solve problem related to this one in different format. You get that? So now let's look at what question one. So now let's take about the first question. Like what I told you, make sure you have your pen, your notebook, and your calculator to follow through here. So given the reaction here, look at the reaction, right? The reaction is what is balanced. So for every question given to you, you must first checkmate if the question is what balanced because at times the question may not be balanced due to mistakes or typographical what error. So you have to balance the equation. So they said if Kc, now here we have two parts. That different question. If Kc for the reaction below, which is on here, is 9.60 at 200 degrees centigrade, what is value of what Kp and this what temperature? So now here, let's start solving. Here you have solution. It's okay. You are looking at what the A question. You are looking at what you are looking at what the A question. So now the question here, uh, they claim the Kc, right? Kc is equals to what? 9.60, right? And the third question given to me, C equals to what? 300 degrees centigrade here. Remember, you have to what? Combine to what? To Kelvin. You are combining to Kelvin. Here we have 300 plus 273, 573, right? Kelvin, right? Then, now I say what is the Kp? Kp, we don't know. You get. Remember, my gas constant is what? 0.0821 atm liter per mole per what Kelvin. It's okay. Now, the next one to do now is what? Look for what? Change n. Remember, uh, Kp equals to what? Kc RT change in n, right? This is the relationship here. So we already know this guy. We know this one here. Away here. We know temperature, right? What we want to do now is what? Calculate what? Change in n. Remember, change in n, I told you that is what? Is summation of the mole of the product. How many mole of the product do you have here? Is what? 2. So it will be 2 minus. Because we only have one product, we have two reactants. So one of the reactants here is having what? 3 plus this one is having what? 1. So if you look at it very, we're going to be 2 minus what? 4, we're going to be minus 2. Then my change in n, we're going to be what? Minus what? 2. You get? So now this is the board condition here. Let us say change in n equals to what? Minus 2. P equals to what? Now my Kc is what? My Kc is what? 9.60 times. Here we have 0.0821 times. My temperature is what? 573, right? 573. Then here we have raised power minus exchange the n. Change the n is equal to minus 2. Minus 2. P is equal to what? 4.338 exponential what? Minus 3. That is what? That is the answer for what? For the A. Remember, here we have Kp equals to what? Kc RT change what n, right? So remember, my change in n is already equals to what? Minus 2, right? My R is already equals to 0.0821 atm liter per mole per what? Kelvin, right? So you have to take some that here. Then now the temperature is different. So my T here, they gave me 500 here, 500 what? Degrees centigrade. Going to be what? 500 plus what? 273, right? 500 plus 273. You have 773 watts Kelvin. You get? So what I'm going to do now? Now the Kp was given to me, right? Kp was given to me as what? 1.45 exponential what? Minus 3. So do what I'm looking for. I'm looking for what? Kc. So what I want to do here now? Now Kc, if you should divide both sides here, make it Kc is your formula here. Here we have Kc equals to what? Kp over what? Rt is over what? N. You get Kp. So when you make Kc formula here, so if you substitute your value, my Kp is equals to what? 1.475 exponential minus 3 over my R is equals to 0.0821 times. My temperature is what? 773. The rest are what? Minus what? 2. Correctly, do what I'm going to get. Kc equals to what? Equals to 5.840. So this is what answer here. Get. So this what is the first question. So you copy it, then let move to what to the next question. So now look at what the second question. The second question is a little bit different from the first question here. So at equilibrium for the reaction, the concentration of reactant and products at 7 to 7 degrees centigrade we found to be what N2 equals to what 0.27 mole per liter, O2 equals to what 0.40 mole per liter, and NO equals to 0.33 mole per liter. What is the value of Kc and Kp at this temperature? Here is what the reaction here. So the first you want to do here is what calculating a calculating Kc. That's the first thing you want to do here. And this is what is the equation here. N2 gas, right? Plus what? O2 gas. Here we have what? 2NO. It's okay. So you want to write the Kc or the equilibrium constant expression. So you have Kc equals what? Constitute what? NO gas is what? Raised by 2 over N2 gas. Here you have O2 what? Gas. You get? So what I want to do here now, there's no point of me writing those figures again because it will already be given to us here. So you have to impute them and we'll calculate. So NO N is what 0.33, right? So 0.33 raised by what 2. So okay, it will already be given to me. Then N2 N is what 0.7 0.27. Then O2 is what 0.4 0. So 1.008. That is the answer here. C RT change what in N. Right? So my RO is equal to what 0.082180 m liter per what mole per what K, right? My T is given to me as what 727 degrees centigrade, right? So we have to go convert to what to kV. 727 plus what 272,000 kV, right? Change the N equals to what? Now the product is what is 2 minus. Here we have reactant here we have 1 plus 1. You have 2 minus 2 going to give me 0. I might change the N going to be what 0. Yes. So how do you calculate it here? Just for me to what impute my values. It's just for me to what impute my values. So it's going to be what Kp equals what Kc. Remember our Kc is what? Okay. Our Kc, we are going to calculate our Kc to be what? Kc equals to what? 1.0008, right? So remember we are going to calculate this one here, right? So we're going to be what? 1.008 times, right? So here we have 0.0821 times. T is what? 1000, right? Raised by what? 0. The whole of this one is going to be 1 because n raised by 0 is what? 1. So instead that my Kp is going to be what? 1.0008. That is what answer. Because the other option is raised by what? 0 here, which is going to be 1. Remember, n raised by 0 is what? Is 1. So this is now what the answer. Again, so now look at what the third one. This one is a little bit technical or complex than what we have done here. So you must pay close attention. So let me divide board here. So here we have, they say that the equilibrium constant Kc for this particular reaction here is what? 4.08 exponential minus 2. Let's say calculate the Kp for this reaction. So in saying that my Kc here has begin to me as what? 4.08 exponential what? Minus 2. Now, they say calculate the Kp for this particular what reaction. So this reaction was given to me. Then I ask you to calculate what Kp for this reaction. That is, the first thing we want to do here is to calculate what Kc for this reaction. If I've not watched my video on how to do this one here, I will leave the link at the description below because this is what you need to understand. You need to understand this one here. You do that. The first one to do here is to calculate what the case of this one here. Once I can get what my case is, then KP will work very, very easy. So, so how do you get our case here? I want to pay close attention here. If you compare these two reactions here, you find that let's say be what K1. Let's just say yes K1, so I can differentiate it here. If you look at it very well, this guy is similar reaction to this other one here. But when you check it very, very well, NH3 is on the what product side, but NH3 is on the reactant side here. Now, the whole of this one here is on the reactant side, but it's on the product side here, right? You know that this one in respect to this one here, it has been reversed. Then this one is a reverse of this one here. That is an inverse of this guy. So that is, yeah, I can say what my K1 equals to what is a reverse of what of the KC here. Do that. Now, but it's only reverse. The moles are not the same. Yeah, how many moles do you have here? Here we have half. Here we have one. But how many moles do you have here? Here we have half. Now, yeah, how many modes do you have here? Here we have two. How many modes do you have here? Here we have one. So if you segment the variance, the difference between these two here is half. That makes sense here. So you say that when you multiply it by half, you get this reaction here. So the reaction is not only what it's not only reverse, but it's also being multiplied to by what half. And anything you multiply to with, you raise to what the power. Do you get that? So my K of this reaction here, so it's now going to be remember my case is what 4 this point one here is what 4.08 exponential what minus 2. So here I can say K equals to 1 over what 4.08 exponential minus 2 or what uh, 4.950. Do you get? So then my new KC for this reaction KC equals to what 4.950. Now, if you don't understood how we got this one here, then they need to what check my video on where I did this one extensively. I saw a lot of questions on this. You get so the link will also be at the description below. So you have to check it out how to. So since I've got our case here, KC equals what 4.950, right? So we are looking at KP. Now the T is what 200. So I have to what change what to came by what 273, right? So 200 plus 273 we have 473 K, right? Now my R is what? My R equals to gas solution 0.0821 ATM liter per mole per what kV. You get so what will be my change in? Change in n going to be what? Half plus half. Here we have 1 over 2 plus 3 over 2 minus 1. Get we have 3 over 2. So if you should evaluate this one here, if you evaluate this one here, remember when you evaluate the two of them, here the LCM is what is 4, right? So going to be 1 plus 3, right? 1 plus 3 equals to what 4. So if you evaluate this one, here I have okay. If you evaluate this one here, here we have 2. 1 plus 2 is what 4. So if you evaluate this one, you're going to have 4 over 2 minus what 1. So we're now going to be 2 minus 1. We're going to be what 1. We'll be what 1. So if you evaluate this one here, you now have 2 minus 1 which is what 1. So my change in n going to be what 1. You get n is going to be what 1. So my chain here equals to what? 1. KP is equals to what? KC RT change what in N, right? So what do you want to do here? Compute my value. My case equals to what? 4.950 0 dot times 0.0821 times we have 473. This for what? 1. So you have like KP is going to be what? 192.2. That is what answer. So you can go over this video again for proper what understanding. So if this video is helpful, please I would like to hear from you. If this video is helpful, please leave it at the comment section because now when I hear from you, that is what I know that what I'm doing here is actually what help you because I know I've not talked to spirit at the other side. I've not talked to what students who are what pray for the exam, and the more I hear from you, the more it's like it gives me that motivation, that drive to what produce content for you, knowing that students are actually what following my content that is actually helping them. So I would like to hear from you at the comment section what you think about the video. If this video is helpful, if there's any topic that is in your head that you want to create for you, then leave at the comment section. You get. I'd like to hear from you. If you're not subscribed to the channel, please hit the subscribe button and turn on the notification bell because we upload content most times 3 to 4 times a week that will actually will help you. So if there's any content or any topic you wish me like for me to create, you get leave at the comment section. You can also what share this video with your friends and your classmates too, so that they too can what benefit. Get the goal here is to what get to 1 million students. You get that what make them to what pass chemistry easily. So I believe the goal is achievable. So thanks for watching. See you in the next video.